Welcome to the Explainer team. I am your head coach, and today we are breaking down the official game film for Cambridge AS and A-level mathematics. Specifically, we're targeting Topic 4.2 Kinematics, diving deep into displacement time and velocity time graphs. Listen, this topic is on the field in every single examination series. It's always there, so mastering it, that's absolutely non-negotiable if you want to secure those top marks and take home the championship this season. We are treating this past paper like the tape of an opposing team, identifying their play patterns so you can strike back. Grab your playbooks, get your highlighters ready, and let's get to work.
Okay, let's look at today's game plan. We are going to start with the pre-game scouting report to understand the examiner's defense. Then we'll open up the tactical playbook, spend some time breaking down the tape of past candidates, make our crucial halftime adjustments, and finish out with your game day preparation checklist.
First up, our pre-game scouting report. If we want to beat the exam, we first have to understand the theoretical architecture of our opponent's strategy.
So, the absolute most crucial point here is that mastering displacement time and velocity time graphs isn't just about throwing a bunch of random numbers onto a page and hoping something sticks. It demands systematic analysis and rock-solid evidence-based reasoning. The examiners are basically building a defensive wall right in front of you. To break through that wall, you must define the stages of your graph mathematically. Think about it. Is the line straight? If it is, you know you're dealing with constant acceleration. But what if it's a curve? Well, suddenly you're facing variable acceleration, and that means you need to pull calculus out of your toolkit. You have to analyze the motion stage by stage, piece by piece. There are absolutely no shortcuts here.
And this brilliantly illustrates what the principal examiner reports tell us directly. The candidates who truly score high, the ones who overwhelm the marking rubric, are those who reference cross-topic connections and establish clear causal relationships. For example, let's say you're looking at a velocity time graph. You need to realize that calculating the area under that line isn't just a basic geometry exercise. You are physically linking kinematics to integration to find the total displacement. Or what about finding the gradient of that line? That's differentiation right there, giving you the acceleration. Connecting those dots across the syllabus is exactly how you score the big points on game day.
Now that we've scouted the theory and we know exactly what the defense expects from us, let's open up the tactical playbook and look at your offensive framework.
We are moving to the main play now. Every single time you face a kinematics question, I want you running this standardized sequence. Think of it as your guaranteed offensive drive down the field. First, identify the key elements. Are we starting from rest? Is the acceleration a constant number, or is it a function of time? Next, apply the relevant principles. If it's constant, you're using your SUVAT equations. If it's variable, you're using calculus. Then, you execute the analysis, but don't stop there. You must verify your results. If you get a negative velocity, pause and ask yourself if that makes sense. Usually yes, it just means the particle has experienced a change in direction. Memorize the sequence. Run it every time.
Now, your execution of that final presentation step, it absolutely must be flawless. That means strict adherence to conventions. You need proper headings, precise terminology, appropriate formats, and crystal clear annotation. Picture one of our players. Let's call him Sam. Sam is a fast attacker, super quick to solve, but man, he is sloppy on the command words and drops his unit formatting all over the place. If you draw a velocity time graph, you better have those axes labeled with the correct units, like meters per second or meters per second squared for acceleration. Leaving an axis unlabeled is literally like fumbling the ball right on the 1-yard line. Just don't do it.
All right, let's hit pause on the tape right here and actually look at what separates the rookies from the top-scoring championship candidates. Let's look at the breakdown. We just talked about Sam being fast but sloppy. Now consider another player, Alex. Alex plays a heavy defense but lacks speed. Alex gives purely descriptive answers, merely stating something like, "The particle speeds up," without actually calculating the gradient to prove it. Notice the stark difference between Alex and Sam's rookie execution and the pro execution we actually want. Rookies just describe what the graph vaguely looks like, but our pros? They evaluate the actual numbers, they calculate the exact time the particle comes to instantaneous rest, and they justify every single decision with hard, undeniable mathematical evidence. To execute at the highest analytical level, to get players like Alex and Sam up to that pro tier, your answer must identify limitations and alternative interpretations, evaluating exactly how they impact the final conclusion. When we draw up a tactical play to counter an intricate evaluation prompt, I want you using a formula we call PEAL. That's P-E-E-L. Point, equation, execution, link. First, you make your point about the kinematic behavior. Second, you state the specific equation you're pulling from your graph. Third, you execute the calculus or algebra. And finally, you link that numerical result back to the physical context of the particle's journey. That is how you clear the path to full marks.
Time out! We are heading into the locker room for some crucial halftime adjustments based on direct intelligence from the examiner reports. Real quick, if you want to stay at the top of the league table this exam season, hit pause, subscribe to Ace the Exams, and enable all notifications right now. Okay, back to the whiteboard.
The examiners are throwing major flags on the field for 3 specific penalties, and we need to clean these up immediately. Penalty 1, vague answers. Just saying the particle speeds up isn't enough. We need specific details like constant acceleration of 2 meters per second squared. Penalty 2, sloppy formatting. We just talked about Sam forgetting those axis labels. Penalty 3, ignoring the specific context. Listen, if the problem is about a car braking and your calculated final velocity is somehow positive or your acceleration shows an increase, you have completely missed the deceleration context. The math has to match the physical reality.
Now this right here is the ultimate examiner alert. This is your absolute lifeline. Show you're working. The method mark strategy is exactly how you salvage points even if you fumble the final numerical answer under pressure. Think about it. If you correctly set up the integral for displacement using a velocity-time equation, but you mess up the final arithmetic in the heat of the moment, the examiner will still give you points for the method. Never, ever leave your working blank. Write it all out.
All right, team, get off the bench. It's time for an interactive drill workshop to test your on-field reflexes. I am putting a 60-second visual timer in your head right now.
I want you to spot the penalty in your own past answers. Think fast. What specific action takes your kinematics answer from a basic, unsupported descriptive assumption to a full-mark, mathematically justified top tier? What is the one thing those examiners are begging to see on your paper?
Boom! There it is. It's questioning assumptions and backing up your decisions with rock-solid mathematical proof. If you're going to assume acceleration is constant, just because the velocity timeline looks straight, you have to prove it by calculating the gradient. That is exactly how you execute a flawless, full-mark answer string.
The clock is ticking down to 0, team. Let's finalize our strategy with the ultimate championship recap.
Lock this checklist in your memory. This is how Alex and Sam finally pulled it together for a perfectly optimized performance. Master and run the standardized sequence every single time. Show absolutely every step of your working to capture those crucial method marks. Keep your answers context-specific and packed with detail. Apply those cross-topic connections to calculus whenever you can. And please, double-check your formatting and your axes annotations before you even think about handing that paper in.
Our explainer film session is over, so I leave you with this final challenge. Are you going to let vague answers and missing axis labels cost you the championship, or will you execute the playbook to perfection and secure every last mark? The choice is entirely yours. Leave a comment down below with your current tier and your goal grade. Make sure you hit that subscribe button for Ace the Exams and ring the notification bell so you're locked in for our next film session. Now get out there, execute the plays, and ace it.